Good morning, everyone. Welcome to my channel. And I'm really excited to welcome you all to this session on a topic that's shaping the future of how we build and manage both software and machine learning systems. So, today we are driving into the world of MLOps, and this is the most powerful approaches that help automate and also streamline how we deploy code and train machine learning models. So whether you are a beginner, a software developer, or a data scientist, or just curious about how all this works behind the scenes, you're in the right place. So we will start with the basics, basics of how MLOps works. What are the differences between MLOps and DevOps, and where actually MLOps will be used, and also one simple working example of MLOps, how we were doing it manually, how we were building manual machine learning models, and now how it has been automated. Everything will be seen. So let's get started. And we shall start with the introduction to MLOps. Like before deep dive into the concepts, we should know what it is exactly. So imagine you built a robot that can guess your mood by just looking at your face, like whether happy, sad, or sleepy. But now you want to teach it better every day and make it work for many people, and also fix it if it makes any mistakes. So, which means that you should train it every day, you should deploy it whenever the new data comes in. Again, it has to be deployed, and if it makes any mistakes, it should be monitored. Okay, so you get it right. The three words training, deploying, and monitoring is all MLOps. It is called as. Basically, MLOps is a superpower that helps you build, test, share, and also care for your robot automatically and continuously. Technically speaking, it is a set of practices, tools that combine software engineering, data science, and operations to enable automated deployment, monitoring, and management of machine learning in production environments. So the main aim of it to streamline the entire machine learning life cycle from data preparation and model training to deployment and maintenance. So you get it right. So that is all about MLOps. Now, how it works. So MLOps works. It basically has six blueprint. We call it as a blueprint. The six steps in the blueprint. In that, the first step is data. So you should gather enough information. Like for the previous example I told, no. So we were supposed to build a robot, and that robot has to predict by looking at the face of a person whether he is happy, sad, or sleepy. So in that context, what is the first step is gathering of the information is first step, like photos of the faces. And after gathering all the information, we should train it. We should teach the robo using those data. And after training it, we should test it whether it has learned correctly or not. So after testing it, how do you test? By checking it. If you feed any new photo, it has to predict whether the face is happy, sad, or sleepy. So that is what we call it as testing. And once it is done, once the testing phase is over, and if it has learned correctly, then next stage is about the deployment. So deployment is you should make it available on the site or on like an app. You should make it available and it should be used by the user. So that is called as deployment, deploying it. So monitoring is keep checking if it still works well. So once you deploy, you should not leave just like that. No, if any error comes in after the deployment, also you should be checking it whether it is working for all the new coming datas and all. So that is what is more important. And after that, updating it. Teach it again if it is needed. Okay, so if there is any critical data coming in and if it is not predicting it correctly, and you should probably go back to the teaching stage and then you are supposed to teach it again if it is needed only. So all these steps are managed using MLOps tools and processes. All these steps are made automated. So this is the complete blueprint of MLOps working. So data collection, training it, and then testing it, finally deploying it, and after deploying it, you should monitor it and then updating it. So this is the complete working of MLOps. So now, so I think you get it right. So now, once you know the working stages of MLOps, working steps of MLOps, so it is very, very important to know the difference between DevOps and MLOps because you have already learned DevOps, right? So now, what is the differences between DevOps and MLOps? That is important for us to know. Here are the major differences between MLOps and DevOps. So first is goal. Goal of DevOps is to deliver software fast, but goal of MLOps is to deliver ML models fast. So if there is a code changes, DevOps is focused on the app application code, but MLOps is focused on both the code and also the data. Observe here. So DevOps majorly focused on application code, but MLOps focuses both on the code as well as on the data. And also when it comes to testing, uh, it tests the features and also the functions in terms of DevOps, but in terms of MLOps, it tests the accuracy and prediction. And when it comes to continuous integration and continuous delivery, so DevOps it uses continuous integration and continuous delivery tools for application releases, and whereas in case of MLOps for model and also training and also deployment. Okay, so for the ML models it will train and then it will deploy. So, and also there may be a possibility of uptime and crashes in terms of DevOps, but in terms of MLOps, it is all about accuracy and the data drift. So these are the major differences between MLOps versus DevOps. So I repeat once again, DevOps, it is the completely focus on software delivery fast. MLOps, it focuses on model delivery fast. DevOps is focused on app code, whereas MLOps focused on both code and also the data. And DevOps, it only tests the features and the functions, but whereas in case of MLOps, it tests accuracy and prediction. And DevOps main concentration is on the app releases, continuous integration and continuous delivery of the application, whereas in terms of MLOps it is training of the model and then deploying it. Okay, so these are the major differences, and I have taken simple example to make you guys understand more on the differences between DevOps and MLOps. In that, let's deep dive into why DevOps is not enough for machine learning. So here you can see in the first image, I built a fruit classifier application using machine learning. So assume that I'm a developer who built a fun little machine learning model that classifies fruits as an apple and an orange based on their weight and texture. So I developed it using DevOps. Everything is live, and I have used DevOps to deploy the application, and it helps with that DevOps helps with things like automating the code, deployment, uptime, and also server management. So application is now live and running smoothly, but my predictions are going very wrong. It's confusing apples with oranges. So here you can see I have trained the model with 180 as apple, 170 as apple, and 180 as orange. Okay. But after a few weeks, something strange happens. The model start making incorrect prediction. It says an apple is an orange and vice versa. So the accuracy drops. Here in this case, you can see I have trained the model on these two datas, 180 as apple, 170 as apple, and 180 as an orange. But whenever new data enters into the model saying 180 and I am smooth, 180 smooth should be apple, right? But 180 and it is also smooth. It should be apple, but it is predicting it as an orange. The model is predicting wrongly. So what I need is MLOps to retrain the model whenever a new fruit data comes in. So here the twist is it was not the application or the code that changes, it was the data. New fruit data that has come in, but the model has not learned from it. So that's why we need MLOps to automatically retrain the model and keep predictions accurate as the data evolves. So, so here in the last picture you can see whenever new data enters into the model should be retrained and then make the prediction, and now this time it is predicting it as an apple. Now model has learned from the previous past data and now the prediction is going to be correct. So understood, right? So once this simple example will give you the complete overview of what DevOps does and what MLOps does, right? So MLOps cannot alone fix it, okay? So it can just auto deploy, restart if anything like crashes happen or monitor server down. So it can handle all those things. But DevOps has no idea that your model is now inaccurate because it doesn't track the data changes. That is the only difference. Data changes cannot be tracked by DevOps. It doesn't retrain the model. It doesn't log accuracy drop, okay? So, but what MLOps does is MLOps watches not just the code but also the data. If assume that data.csv, there is a file data.csv and there is a changes in that data, it'll if there is a changes in that data, it will automatically retrains the model and also logs the new matrices that like accuracy etc and deploys the updated model to the prediction. So predictions stay fresh and also accurate as the data evolves. So that is the major difference. So here you can see there is something called as data drift, right? So here what happens is when the data changes, that we call it as data drift. So initial training data, this is initial training data. When we first train a model, it learned from this data. For example, fruits like apple and oranges with a certain weights and skin texture. Based on this, model figured out a good rule. So maybe something like if weight is above 150 and skin is smooth, it is an apple. Like that, it has figured out something like that. But when new data appears, now over the time we start receiving new fruit data. Maybe the apples of this season are heavier and or the oranges are smoother than before. So these changes are subtle. So but the model has not seen this kind of data before. So its predictions start becoming wrong. So model continues predicting based on old rules. So model still thinks 180 is an orange because that's what it learned earlier. So even though new fruit 180 are apples now, this mismatch between the model knowledge and the new data is called as data drift. Okay, so mismatch between the model's knowledge and also the data new data is called as drift. Okay, so that's what we have written here. Earlier we trained apples are more bigger than oranges, but here when a new data enters, so it has predicted wrongly. It should be predicted as an apple, but it has predicted as an orange. Okay. So to fix this, we need to retrain the model using updated data set. So MLOps helps us automate this process. So whenever the data is updated, model is retrained, evaluated, redeployed automatically. This is what it say. It stays accurate and updates over the change over the time. So just like we update our maps when roads change, we must update our machine learning models when data changes. So that's what makes MLOps essential. It keeps models fresh, reliable, and intelligent in the real world. So next we have where MLOps are used. You know it, right? When there is something called as an automation, then automated things are being implemented in hospitals, self-driving cars, and also many of the applications and shops. So these are the few of the areas we could find MLOps usage. See, I have one example of training a model manually. So we should know, in order to know MLOps properly, you should be knowing the manual implementation of the machine learning models and now how it is being automated. Okay, so for that I have taken the simple working example. So the example is simple. We have to train a model that predicts if a fruit is an apple or an orange. Simple. Okay. So for that, it is necessary to import all these libraries like this. Okay. So if you are familiar with Python, then you might be knowing what are these libraries. So if not also, don't worry. I'm going to explain each and every line step by step. So here we are taken this one import pandas as PD pandas basically help to manage data in the table format, okay, like in the format of Excel. And next we have the train the test a split. So this is basically helps to split the data into training and also into testing part. Okay. So if we have 100 number of datas, so this library will basically divide that 100 data in 80 as a training data and 20 as a testing part. Like that it will divide, and we can divide however we want. And for this, to train the model, we are using logistic regression, a classification model. Okay, a simple machine learning model we have taken into consideration that that can classify the things. And also, so here you can see one more thing called as import pickle. So it let us save and also load the model to and from a file, like saving a game like that. Okay. So now, understood, right? These are the libraries we require. And now we are creating fake data set of fruits with weight and smooth. Okay. So smoothness is one, you know, it should be labeled as apple. 0 for rough, it should be labeled as an orange. Okay. Apple and orange. So, but here you can look at this. So the weight should be weight sample data. How do you collect the sample data? We have created manually. So data is equal to, inside the brackets you are supposed to add all the features. These are the features: weight, smooth, and label. So weight, these are the weights. And if 150 and also smoothness is 1, it should be apple. 170 smoothness is 1, apple. 140 smoothness is 0, then orange, label. 130, you can see lower weights or tend to be orange, higher weights or tend to be apple. Like that we have divided, and this is how you should write it in the form of a code. And then next we have this one. So think of this like a spreadsheet or a table where you can easily view and process the data. So previously data in the form of CSV file, that should be to take it for the processing, we should divide it like a spreadsheet. We should form it like a spreadsheet. For that we are using data frame of data. Okay. So on this data we should form an Excel format, and that should be stored in this. That's what it says. And next, and the fourth step, what we do is we're going to split it into features and target. Okay, so here we are filtering into features and target. Features are nothing but which is used to predict. Okay, so using the features we can predict. Labels are what we are trying to predict. Okay, so what we are trying to predict basically. Features used to predict weight and also the smoothness. Okay, and also it is called as an input. Okay, so input or weight and smooth. If we give the weight and smooth as input, based on that features model has to predict whether it is an apple or an orange. That is the code here. Okay, so weight and smooth are the input features to be predicted, and y is the output. Okay, so what we are trying to predict, that is the label. So that is what. And now in the next step we create a logistic regression model. Okay, so we are training the model now. So we train the model using this function fit of x comma y. Okay, so this means look at the inputs and learn to predict the label. Okay, so fit of x comma y is nothing but look at the input and predict the y. That is what it says. Now we are saving in the next step we are just saving the model to a file called as fruitmodel.pkl. Okay, so this is we are saving a model, trained model. Okay, so trained model into this file, basically saving your project so you can use it again later. Okay, okay, you can just use it again later, and your model is trained once and saved. It will be trained only once and then it will be saved. Then someone else maybe on the website can load it and use it. Okay, so whenever new data enters like this, it will say, for example, now this time here loading the model. Okay, so when a new data enters like 145 and 0, if it is 145 and 0, model checks and it will look at what did I learn earlier and it guesses is an apple or an orange, and it will print the result on the screen. Okay, so summary is we should import the libraries, create a data set, convert it into a table format, and split the data for training and also for the purpose of testing it, and train the model to learn the difference, and also save the trained model to a file, and after that load the model from the file and predict the new feature. So that is the I mean this is how we usually train the model, right? So here you should know what is logistic learning. Okay, so logistic learning, you know that it is used for the classification, right? So think of it like this. You want to answer yes or no question. Say for example the question is this a fruit? Is this fruit an apple or an orange? So it tries to draw a line to separate apples from oranges based on the features like weight and smoothness. It then calculates the probability that the input is an apple and classify based on that. Okay, so logistic regression uses a math formula. Okay, this is the so in the previous example, you saw how do we import the libraries, how do we create a data set, how do you train the model, like that. Everything was manual, right? We wrote the code and we trained the model and we tested it. Everything was manual. And whenever a new data enters and we were supposed to train the model again and then we would give the input to the model, so everything was manual. So here in case of MLOps, what it does is it creates a pipeline. Through the pipelines every step will be run automatically. That is the beauty of MLOps. Okay, it uses a set of tools to automate training, saving and also deploying. Okay, so here it uses version control. This involves tracking code changes and also the data and model using the tool like Git. We have Git, no? So which maintain a history of all the changes. And we have a continuous integration and a continuous deployment tool, which will automate the process of building, testing, and deploying ML models using tools like you have already seen it in DevOps like Jenkins, and we have Travis as well. And third option we have is containerization. So that is packaging all your ML models dependency into the containers using tools like Docker or Kubernetes, which enable easy deployment and also scaling of models in a production environment. And the fourth option that we have is a model serving. Model serving involves setting up a server to host the ML models and serving predictions on incoming data automatically again. And also monitoring, and for monitoring and logging we have a automated tool called as Grafana. And like we have so many in that, the Grafana is familiar to me. So this involves tracking the performance of the ML models in production environments, and also alerts to enable proactive maintenance. Okay, so basically we have Git for code changes, CI/CD like Jenkins we have, containerization Dockers we have, and also deploy for deploying it we have like yeah, model serving we have, and for monitoring and logging we have Grafana. So that is about manual versus automated pipelines. And few of the tools which are available to automate the things with MLOps is this ML flow. So basically, ML flow, which will track the experiments version and models. And we have airflow as well. Airflow, which schedule and also run the steps like a flow chart. Kubeflow, we have advanced orchestration of ML workflows, and GitHub Actions we have for automatic training and deployment from the code pushes, and data version control, that is DVC we have for track changes, and also model like Git track code. And what this pipeline does is when a new data arrives, it automatically train the model, check the accuracy, and deploy to the server, and it monitors. That we in the entire package we call it as a pipeline. So what we did here, we imported all the packages manually, we created data manually, we trained the model manually, we saved it, loaded it, predicted it, everything was manual. And in the next video, I'm going to show you how all these things, all these six steps can be uh, pipelined. How the MLOps will automate things. To the same example, we will see. Thank you.